Let us discuss a question from engineering mechanics. So basically we have a ladder and some combinations of friction forces or some combination friction coefficients are given at the wall and as well as the vertical, the wall as well as at the horizontal level. So we are asked to find which is true when it is about to slip. So about to slip is treated as when it's just in equilibrium and the friction is limiting. So what we do is we do case by case. First we take we'll take mu1 is equal to 0, okay, and mu2 is not equal to 0. So mu1 is equal to 0 and mu2 not equal to 0. So in this case mu1 is this part, so mu1 is 0 and mu2 is not equal to 0. So this is 0, so you don't have any friction here, so only the forces are n1 n2 and this is about to slip here, so you will have mu n2 here, mu2 n2, and mg will act in this way. So this is theta, okay, and yeah, that is angle theta with the horizontal level. So this is with the horizontal level theta. So now what is n2? N2 at this point, if you balance the force, n2 will be equal to mg, and n1 we need to find out. So n1 you can take a moment about this point. So n1 into this total y, let's call this as y. So n1 into y, that has to be equal to mg into okay, that the moment produced by n1 is anti-clockwise, mg produces clockwise moment, so mg into this distance. So let's call that distance to be x. So this is x, mg into x. Now y and x, how they are related? Tan 2 theta or tan theta is opposite by adjacent. So adjacent is 2x because this is mg, so this is x and this will be x because this is L by 2 and this is L by 2. So this has to be x, or x I think I can write as L by 2 sine theta. So okay, I mean, instead of getting confused, what we can do is we can do one thing. Y and x we need to relate. So sine cos theta, okay, so cos theta is, so mg into this distance, okay. So let's write y and x in terms of L only, so that will avoid any confusion. So y is nothing but L sine theta, yeah, L sine theta, total L sine theta is y mg. X is nothing but this, x is L by 2, sine theta will be this, cos theta is this, so L by 2 cos theta. So n1 is mg by, okay, mg into okay, so mg by mg by 2 tan theta, okay. So these are the forces. So n2 is mg and n1 is mg. So let's see for this case. So this is wrong because n2 we get as n2 is mg for this case. So n2 is mg, so this is wrong actually. So P is not correct. Now that same case is mu1 mu2, and that case we get n1 tan theta is mg by 2. So that is what we are getting. So this is correct, okay. And now coming to the another case where mu1 is 0 and mu2 is 0. So you have to take cases by cases and solve this problem. So now case where mu1 is not equal to 0 and mu2 is 0. So mu1 is not 0, so it will tend to slip here. So and this is n1, this is mu1 n1, there is no n2 here, n2, and there is mg. So this will not be in equilibrium because this n1 will not be balanced, okay. So that is one thing, because there is no friction at the left and mu2 is 0, so this cannot be in equilibrium actually. N1 will not be any force, so Q is definitely wrong. Now coming to a general case where we have both mu1 and mu2. So in that case you have friction like this. This is n1, this is mu1 n1, this is n2, and this is, sorry, this is n2, and this is friction mu2 n2, and you have mg. Okay, so we take moment balance about the left end, so then we get the same okay. So then what will happen if we take the moment balance about this? So N2, basically we need to find out N2 here. So what you can do is probably is balance the forces first. So if you balance the forces in x and y direction, so N1 is mu N2, N1 is mu N2, that is in the x direction if you balance the force. If you balance the force in vertical direction, N2 minus mu 1 N1 is equal to mg. So I think we can get from this only, we need not use the moment thing. So N2 is mu 1 N2. Okay, so here as it tries to slip, as it because of this weight it tries to slip in this way, so this point will go upward, so you have a friction this towards left, so we have a friction like this point has to move downwards, so friction will be upwards, so and now if you do the force balance in x direction, mu 2 N2 is N1, that is what we have written, summation of force in x direction. Remember we are considering a third case where both of them are not 0. Now in the vertical direction we balance N2 plus, because it's also in upward direction, mu1 N1 is mg. So now N2 is something we need to find out, so N2 substitute for N1, so N2 this is again mu1, this is mu2, this is mu1, so N1 is mu2 N2, so mu2 N2 is equal to mg. Okay, so N2 is basically mg by 1 plus mu1 mu2, so this is correct. So R and S are correct, P and Q. So consider case by case and then just statically balance it, force balance or moment balance. Okay, so R and S is correct, answer is C. Thank you.